Okay, hello everybody. You have joined the Access NASA Land Processes Data with Web-Based Services webinar. This is your host, Jennifer Brennan. While everybody is logging in here, we do have two optional polls. You'll find those at the bottom left and middle of the page, and we do appreciate your feedback on those polls. I do have 2 p.m. Eastern Daylight Savings Time, so we are going to go ahead and get started. So first what we'll do is we'll touch upon a few housekeeping items related to this webinar. To ensure the best audio experience, the conference has been placed in silent mode. So if you have any questions or you have any issues, please enter those into the Q&A pod located on the lower right-hand side of your screen. This works like a chat. Okay, great, Dimitri. I hadn't been talking at the time you had typed in. This webinar is being recorded, and it will be posted both to our online Adobe Connect webinar catalog as well as to our NASA Earthdata YouTube channel within a few days of completion. I will provide the URL to you at the end. Also, all of the presentation files will be available for download at the end of the webinar. As far as timing is concerned, this webinar is 1 hour long. We've allocated 45 minutes to the presentation and live demonstration, with an additional 15 minutes for the question and answer period. So after our speaker has finished his presentation, what we'll do then is we'll move to a final set of polling questions, and we will pick back up with the question and answer period, which follows directly after the final polling questions. So remember, you will have an opportunity to ask your questions throughout all portions of the webinar with the exception of the live demonstration. And you'll do this again by using the Q&A pod located on the right-hand side of your screen. So due to the large number of participants, questions will not be answered using the raising hand function. It has been disabled. Again, we'll take all of the questions at the end using the Q&A pod. And one final note, depending upon the volume of questions that we receive, we will extend the Q&A period an additional 15 minutes to 3:15 p.m. Eastern Time for those of you who may wish to stay on the line. So what I'd like to do next is move to our agenda. I'll give this a second here. During the first few minutes, our speaker will provide an introduction and overview of the NASA Land Processes Distributed Active Archive Center, or LP DAAC, Big Earth Data Initiatives, and that acronym is BEDI. Following the introduction, our speaker will spend 20 minutes or so on OPeNDAP data access basics, and will follow with a more in-depth discussion on how to use NASA LP DAAC middleware services in conjunction with OPeNDAP. Next, we will transition to an overview of the higher-level component AppEEARS and a live demonstration for this point-based extraction tool. Finally, we'll wrap up today's webinar with future plans and activities. With that, it is my pleasure to introduce today's speaker, Jason Werpe, who is the Enterprise Architect at the NASA LP DAAC. Jason?
Thank you, Jennifer. Like Jennifer said, my name is Jason Werpe. I am the Enterprise Architect at the LP DAAC. Today I'm going to be talking about what the LP DAAC did in response to the Big Earth Data Initiative, BEDI, like she mentioned before, and how we developed web services to meet that initiative and serve our customers. First, a quick overview about the LP DAAC. The LP DAAC is the Land Processes Distributed Active Archive Center from NASA. It is one of a handful of NASA DAACs, and we are located at AROS Data Center in Sioux Falls, South Dakota. As you can see on this slide, NASA has quite a few discipline-oriented DAACs, and the LP DAAC is there right in the middle. Other DAACs look at data, for instance, with respect to atmospheres or oceans, and LP is the Land Processes DAAC. What I'd like to talk to you about today is what we did in response to the Big Earth Data Initiative, or BEDI. NASA put forth an initiative a year and a half ago to increase the accessibility of earth science data for users. They also wanted to increase the availability of that data and increase the usability of that data. So the LP DAAC was tasked with figuring out ways to make those kind of things happen and make improvements on those aspects of users using data from the LP DAAC. So in our response, we decided to address the goals, we would work on services designed and architected to give users that improved data visibility, access, and tools. So we decided how we were going to do that and came up with a tiered concept. This slide here kind of shows a overview of the tiered concept that the LP DAAC responded with. At the bottom, we have services that we call data services that directly access our data. So we have a data pool, and the data pool labeled here represents the archive of the LP DAAC. The LP DAAC archives quite a bit of MODIS data, so we are accessing that MODIS data on the data pool. But that data layer, and part of the idea with accessing that data layer was to use OPeNDAP services. I'll explain OPeNDAP services in more detail as we go on through the presentation, but for the sake of this slide, it just means that those services directly interact with the data and deliver the data to the user per how the user requests them. But they're not exactly the simplest services to use. So in response to that, we created a middleware layer. This is a middleware web service layer where, as you can see on the slide here, we have a bunch of different endpoints. Those are web service addresses that we use to call out the web service, and then the web service itself interacts with or can be used with OPeNDAP to get the data. So that's part of our middleware. It's in the middle. It doesn't do everything you need to do, but it ties things together. On top of those layers, we have a service interface, which is a web API. This involves higher level services, endpoints that serve the user interfaces, endpoints that fulfill data requests, different API tools that are just built at a higher level than just the middleware and can do full things to get data all the way through the stack. And then in addition to that, we have application user interfaces that we create where you have a web app, where it looks like an application on the internet, and you go in and you utilize it, and it ties all these services together, but the user just is using the web app at that point and doesn't have to directly interact with the services. At the end of the presentation, I'll show the AppEEARS interface and show how that UI was developed and utilizing these services. As you notice on the slides, I lay out these tiers: data services, middleware, API, and UI, and I will actually bold as we move through the slides what type of service I'm talking about on the particular slide in the presentation. Now, a quick aside, getting the data. I want to mention for a minute why we chose to use HTTP services. HTTP services are hypertext transfer protocol. It's a means of delivering data that the web uses. We chose that because it's simple. We chose it because it's a standard-based protocol. We chose that because it's securable. You can use HTTPS to secure the data. And it also has dynamic interaction methods. Users can ask for specific things. They can provide parameters and get different responses back through HTTP services based on what they say. It's also a stream-based method of data delivery. And I'd like to take this aside even further and go that it's even shown as a good way to get data in the future. I have a couple pictures here from different entertainment items out there. The one on the upper left there is from The Matrix, and if you've seen the movie The Matrix, one of the things that happens in that movie is the inhabitants of that world interact with a virtual reality system that presents a world. But when they're outside of that, they look at computer screens and they see this text streaming down. And as that text is streaming down, people in that universe can look at that text and see that text streaming, and the data just coming through in a stream, and see the matrix. They can interpret it as the matrix. They can interpret that data stream as they see it. The other slide here is actually a picture of Data, the android from Star Trek. And in many cases on that show, you'd see scenes like the one I have depicted here, where he's looking at a screen and text is just flashing by, a big stream of text that's coming through, a stream of information that's being interpreted. So in these two examples of futuristic means of conveying information, streams of data, data that comes through and you just get the data and it's in a textual format, it's viewed as a means of getting that data in the future. And it's a means that HTTP enables us to do with our web services today. So we have streams of text data or streams of data coming across that deliver the information users want to have. I just thought that was a nifty aside, that happens to be seen in other venues that appear to be futuristic. Data access methods. I'm going to dive into the layers that we have here in a little more deep detail. For data access methods, like I mentioned before, we use the OPeNDAP capability. An OPeNDAP stands for Open Source Project for a Network Data Access Protocol. It's actually a data access protocol built on top of HTTP that provides a means of putting in a web request and getting the data to stream back out to the users. It provides a direct way of subsetting the data that exists in our LP DAAC data pool. And then, like I mentioned before, we have middleware services. These middleware services are composed of a handful of different services that I'll describe here, and then I'll go through a few more details about these services as we move along. The first service we have that I'm going to talk about is TileMap. When we're dealing with data on the LP DAAC, the MODIS data that we have and also the WELD data that we have, the web-enabled Landsat data, is in a gridded format. So there's a gridded tiled format for that data. And this TileMap function actually converts latitude and longitude locations into tile and pixel values for those gridded data sets in that common grid structure. So we use that to figure out where the pixels we want to subset are. From Julian is a service that we created to convert dates from a Julian date format into a month, day, year format. Our OPeNDAP servers give you information about the dates that it's selecting data for in a Julian date format. It's basically number of days since 1/1/2000 because that's how we defined it. And this from Julian service and the other service to Julian, which converts the dates from a month, day, year format to a Julian date format, is used to convert those dates that OPeNDAP is showing the user. So they can convert them and get them into readable dates that you can use and understand. Another middleware service that we have is the product service. This one's coming soon. I don't have any demos for this one yet, but I just want to explain what it's going to do. We will have this service coming in the next few months from the LP DAAC. It's going to be a service that provides information about the different products we have in our LP DAAC archive. Another service that we have in the middleware services is our inventory service. It's a service that returns information about the granules in the LP DAAC inventory. It is powered by NASA's Common Metadata Repository. NASA's CMR repository has information about all the granules of data that are stored at all of the DAACs. We created the inventory service to give us a nice view of the CMR's information for LP DAAC data sets through our service, and it sorts and categorizes that data in ways that are very useful to our users. And then the last thing I want to talk about is the interface. In the interface, I'm going to show AppEEARS. It's our interface for selecting point-based data from the archive, analyzing that data, doing some early preliminary analysis on the data, and then enabling users to download just the specific values that they're interested in, the specific data points that are of interest to the users. And as Jennifer mentioned, there will be a live demo of AppEEARS at the tail end of this presentation. So I'd like to take more time and talk a little bit more about OPeNDAP data access. We saw OPeNDAP as a key component to NASA's BEDI efforts. And the BEDI efforts focused on OPeNDAP as a means of getting at data at the different DAACs. As I said before, OPeNDAP accesses the LP DAAC's data pool and provides information about our granules, our data granules. But as I also mentioned, because the MODIS tiles and the WELD tiles that we have in our data pool are stored in a uniform grid, we were able to create aggregations of that data by date. This basically allows us an extra parameter to fine-tune our selections of data from the LP DAAC for the dates that are desired through a simplified interface in OPeNDAP. I'll note here that our OPeNDAP services are located at the URL shown here on the slides. I'm going to now go through and look at some of the examples and go through a quick explanation of what our OPeNDAP deployment looks like. This is the main screen that you can see when you access our OPeNDAP servers. You see here we have different products, and these are gridded products, and we also have some grouped directories that will let you see the products based on different categories and go through groups. But basically, if you look here, this MCD12Q1.051 product is actually a Modus combined data product from the Terra and Aqua satellites. If you go into that directory, you will see the tiles listed. In this case, I went down and scrolled down to the directory for the Modo9Q1, the surface reflectance 250-meter product for Modus, and I got the 006, means that's the version 6 product of that data. And if you notice here, I have a bunch of tiles. These are all the tiles that are represented in that data set. So the tile grid for Modus is represented, and you can select from any tile you want. So you pick your product, and you pick the tile you want, and then when you go in to that tile, you can pick information about that tile. Here I show what that request looks like. You see a form, and this basically allows you to do an interactive HTTP request. You can also, if you know how OPeNDAP works, build your HTTP request from scratch, and I will show that here in a second. So you get this screen and can pick out the different layers and pieces of that data set that you want. And because we aggregate for time, you can also pick out which time slices of that data you want and pick out through time and through your spatial coordinates and pick the bands that you want out of that. So like I'm saying, you can access discrete subsets from your data in spatial, in your bands and layers, and through temporal points from the aggregation that we did to aggregate everything by tile location. So if you look at what would happen, you can set up an HTTP request for data via an OPeNDAP URL, and you can see that here on this next line. And it looks rather confusing, but if you know what's in it and know how it's put together, you can understand what it looks like. This URL returns the data that the user intends to use and reduces time downloading and processing that data and minimizes the amount of data downloaded. You're asking for only the pieces of data you want, for only the time you want, and only the area you want, and only the bands that you're interested in. So it's very helpful to the user. But like I said, the URL is a little bit complicated to put together. When we call that request, the OPeNDAP request, if we run that, will spit back out the data. And this is text that's coming back to you as a stream of data for this information. So in this case, I'm getting the surface reflectance band 01 information out of this case, the Modo9Q1 product. So I'm going to back up a little bit and look at the OPeNDAP URLs and see how we build them. And this is kind of part and parcel to how the LP DAAC decided to make our middleware services, because our middleware services serve the function of putting together these URLs and determining what information is in them. So when you put together an OPeNDAP URL, you need to know the syntax for OPeNDAP, and that's represented here in white. You can see the different things with our path there, and with the style of product you're going to get back. We're getting back an ASCII response in this case. You can also get back a netCDF response if you want your data in the netCDF format. That's based on your syntax. The product name is specified here in this color, and you can see the Modo9Q1. In this case, we're looking at the version 5 data. You get the time information here is represented in blue, and you can see that represented here for the band. It's first subsetted by time and then by spatial coordinates. And the spatial geolocation coordinates, as I showed before, is the tile location, this H11V4 in this case, and the pixel location, the Y dimension and X dimension in that tile. So here I've highlighted what parts represent the different pieces of the URL and the components that you're interested in when you're getting data through OPeNDAP. So our utility and metadata services, our middleware services, help you fill in the complicated parts of the OPeNDAP URLs. For geolocation, the tile map service converts the latitude and longitude to H and V coordinates and X and Y pixel locations within your tile. And then, like I said, time information is represented in OPeNDAP as number of days since 1/1/2000. And that's a hard thing to convert in your head if you see a number like 354 or 3,276. Converting that to an actual date is rather complicated. So our middleware services help with those things. And also, continuing on for middleware services, our product service, like I mentioned, gets information about LP DAAC products and the bands contained with these products. So that allows you to pick your bands and know which bands you can select out of OPeNDAP. And then our inventory service is kind of ancillary to interacting with OPeNDAP. In OPeNDAP, we've aggregated all our tiles together, so the files are all linked to the tile that they come from. But those tiles actually exist as individual data granules in our archive. And in our inventory service, you can find out where those granules are, find out information about their metadata, and get more information through the inventory service about the data that your OPeNDAP request is sending your way when you request it from the LP DAAC. So I'm going to go through a PowerPoint demo of these different services. Quick go through tile map, and then build an OPeNDAP request through the OPeNDAP aggregated view, and show you a little bit of what from Julian and to Julian can be used for. And then I'm going to do a few slides that talk about the inventory service and what its responses look like. So I'm going to make a service call, and I'm talking about the web services that the LP DAAC has, but what does it really mean? We don't know how this service works. I mentioned I have the tile map service, and we've got that out there. If you put in the URL for the tile map service, you can type in this URL here on the screen and go to the tile map service. And if you type in just that URL and you don't know what the service does, it actually will tell you. This is one of the things that we did because we wanted our services to be useful and usable by the people who were going to be accessing them. So if you call a service and you don't know how it works, it's going to actually return you a help page. This case, this is the help page for TileMap. It tells you what it does, and it tells you what its parameters are, and it tells you an example. It can give you an example and tell you what its response looks like. So we see here that it takes the parameters product, latitude, longitude, and it gives you an option for what type of output you want. In this case, this example is calling it and looking for the product Motto 9A1 and looking at latitude 42 and longitude minus 100, 100 west. And it gives back the horizontal tile number, the vertical tile number, the line dimension, and the sample dimension in X and Y of that tile. So you can see here, I'm zooming in a little bit on that, and I've picked a few different numbers here. If we call here for Motto 9A1 again, but we put in the numbers 44.306 for latitude and minus 96.7881 for longitude, we'll get back a response that tells us this is now at horizontal tile number 11, vertical tile 4, Y dimension is 1366, and the X dimension is 1726. So on this example, I've highlighted those in the colors that we had for the tile and for the X and Y dimension, the geolocation information for OPeNDAP. We can take this information from TileMap and plug it into an OPeNDAP HTTP URL to determine location and get information from where we want it to be. And here I show a little map. This is the MODIS grid for MODIS data, and the pin represents the location of where our data is coming from and where TileMap located it to be. So with the location being known now, we can create an OPeNDAP call for that location. You see in here that I've put in the H11 VO4 for that data, and I put in the 1366, and I'm getting just that 1366 pixel. This is getting me 1366, get me 1 pixel. Start at 1366 and at 1366, so that gets me 1 pixel. 176, 176 gets me the 176 pixel and only that pixel. So I'm getting information about latitude from my Motto 9A1 product for that. I'm getting information about longitude for that product at that location. And then I'm getting surface reflectance band 1. And I'm pulling out, and I picked some dates. I picked 730, and then I'm getting dates one at a time through 733. So I will get dates 730, 731, 732, and 733 from the array of dates in our aggregation of that data. And you'll see in this response, this is the output you get. You get the response, and you get the latitude information, the longitude information. Those match the latitude and longitude I put into TileMap. And you get the surface reflectance band 1 information, the surface reflectance band 1 information here, more band 1 information, more band 1 information. You see here on this 0, 1, 2, and 3, those represent each of the 4 time slices. And then I got information from my time variable as well. And that told me that the date from 1/1/2000 for that information is date 5860, 5868, 5876, and 5884. This is an 8-day modus product, so we see that we're getting a product every 8 days. But we don't know what days those are in particular. So here's the output again. If we look at the 730 to 733 range of data for those last 4 acquisition dates, and we put them into the from Julian service, as you can see on the next line there, that's the web call for our from Julian service. We'll convert those Julian dates from those date integers into the value January 17th, 2016, January 25th, 2016, February 2nd, 2016, and February 10th, 2016. So now we know what dates those came for. If we wanted to, we could use the toJulian to convert the calendar dates from those dates to calculate the values in reverse, and it just runs the other way. If you told toJulian that the date was January 17th, 2016, it would return you the number 5860 for that date. So you can match the dates to the Julian dates that are used in OPeNDAP to connect our aggregations to their points in time. Other LP DAAC middleware services provide higher level metadata interactions. So this is where I'm going to talk about the inventory service for a little bit. Like I said, it doesn't directly deal with OPeNDAP, but it does tell you what granules OPeNDAP is actually accessing. So you can see which data granules in the archive are the ones where the data is coming from. It lists LP DAAC granules and select granule information, and again, as I mentioned, it's powered by NASA's CMR. Let's take a look at that service real quick. The inventory service returns select information about granules in the LP DAAC inventory. The URL here is represented as lpdaacservice.ucrs.gov/services/inventory. If we call that again, remember, we're going to execute that service without any information. It's again going to tell you how to use it. It's going to give you the help context for that service. In the case of inventory, this is one of our more complicated services, and it has a handful of information for that you can specify to get your inventory off. You can specify product, and there's spatial coordinates, and there's temporal coordinates, and I'm going to just go through here and look at the next page here and show you a neat trick that we can do with our inventory service. If we ask for our help and we say help equals form to our parameters, we can actually get the inventory service to present us a form that we can fill out. And here I have some information here. You can actually now put information in here and press submit, and the button and the service will actually execute. You see here the rest of the information, and you can press submit. So this is a nice way that we added on, another extra special feature that we added on to allow users to utilize the service easily if they didn't know how exactly it worked. We gave them a form context with which they could call the services. That's one neat way of accessing the service, but again, it's also a web service, and you can put in a URL and get information about inventory directly through that. So here on this slide, I've shown an example of an inventory call. We have the inventory service represented here. We're looking for product Model 11A1 version 6. I put in a latitude and a longitude. They happen to be the same ones I used from before, and I put in a date range, date 2010-11 to 2016-0301. So I'm going to get all the data from January 1st, 2010 to March 1st, 2016. So if we execute that call, we get a response back. And inventory gives us a response back. The default is to give us a response back in XML. So you see in XML a list to the URL for all our granules. This gives you the granules in the DAAC data pool that represent these values. If you click on these HTTP links, you will actually download the granules if you cut that link out and paste it into your browser. Another neat feature, and we'll show a few different options on this one, is I can represent the same call again, and I can represent a Julian range and a bounding box. And I can put in bounding box information of the corners of a box for my information. I can put in a Julian range, Julian dates 90 to 132 for a year, and then search a year range 2006 to 2011. So I can look for days 90 to 132 for 2006, 7, 8, 9, 10, and 11. And then I'm asking for the response. And in the response, I'm selecting the kind of information I want to get. And in this case, I want to get the metadata URL. In this case, I'm not looking for the data URL. I'm looking for a link that will show me the metadata about this product. And I'm also putting in an output parameter of HTML, which allows me to look at that data as if it's an HTML web page, which is really nifty, because when we execute this call, we get a data response, and here we have links to that data. If I were to click on one of these links, I would actually download the metadata file. If I had asked specifically for the data file instead of the metadata file, clicking on this link would actually get you the data file in that case. So if I click on one of those links, I get the metadata file, and here you can see metadata information about one of the links that was shown on the previous page. And as I said again, hint, this will work for browse URLs or data granule URLs as well. So if you ask for the browse, you can click on the links in HTML format and get the browse to download, or the same thing for the data granule. If you ask for HTML output and click on the link there, you can download the granule itself, which is kind of useful. With these building blocks in place, then what is next to do? What are we going to put together? We built, like I said, we had that tiered response. So we had the data layer, we had the middleware layer, and now we're looking at API and UI and what we can do. And we put these building blocks out there, and we put them out there for anyone who really wants to use them. So while our services, all our services, our data services, our middleware services, and even the APIs that drive our UI are available to anybody who wants to use them to build their own interfaces and systems. And one of those types of interfaces is AppEEARS. The LP DAAC built the AppEEARS system, which is an application for extracting and exploring analysis-ready samples, utilizing all of our middleware services to some extent to put everything together and give the users a capability that could extract point data from MODIS and WELD data in the archive and give them values back, and also allow them to analyze those values. So we'll look at this web application in a second. Like I said, it's built on top of the services and tools, and the capabilities it has are to easily access a selection of MODIS and WELD land data. It again extracts just pixel values at this time. It provides a means of data exploration and interaction through some dynamic graphs and tables that let you look at the data that you have requested and how it has, what its values are and what its quality information is. And then it also allows you to download a bundle of all of that analysis-ready data. And we'll go through and see how that works here in the live demo. So this is the URL for AppEEARS. And Jennifer, I'd like to switch to the live demo mode and show a demo of the AppEEARS system. Okay, so here we have the AppEEARS interface. This is the LP DAAC AppEEARS client. When we come in here, if you did not have a login, it would ask you to log in here. Our logins are all managed through the Earthdata login system through NASA. So if you have other NASA sites and websites that you utilize to do to get data from or interact with, and you have an Earthdata login, that login would be able to work for AppEEARS and let you log in and access our AppEEARS client. When we look at the client, we have the capability to do extractions or do explorations. I'm going to go into the Extract tab here and look at our point sampler. So for our point sampler, we have the ability to start a new request. We also allow users to copy a request. So if you have a request that you've done and you want to do something just a little bit different, you can copy the old request and do a new request, or we can actually let users upload a request file. As part of the data we deliver to users from AppEEARS, we give them a JSON file that has all of the information about the parameters and values they selected to run their job. And if you want to email that file to someone else and tell them that they should try that in AppEEARS, they could drop that same order in here and generate that order for themselves through that capability. I'm going to click on starting a new request and start a new request. I'm going to give it the name webinar demo, and now I can click here and select a CSV file. You might not be able to see the screen I'm selecting it from, but I picked the file off of my drive, and that file had information that you're seeing here in it, and it downloaded that information into the coordinate box and gave me the labels for the values. I get to have an ID for each data point. I get to pick categories, and those categories can actually be duplicated. So you see I have the category DVF, has a few points in it, and then I have the latitude and longitude value for those points. And these are my points of interest. So a user can upload a file that has these areas of interest. You can also type it directly in this text box if you would like to. Then I need to pick a date that I'm interested in, so I'm going to pick a date from 2015. I'm going to pick 1/1/2015 to December 31st, 2015. So I'm going to pick the entire year 2015. I could also select recurring dates if I wanted to, but I'm just going to pick the entire year for this. And then, because of the way OPeNDAP is structured, I'm going to pick the product and band that I want to get, and then AppEEARS is actually going to be capable of figuring out what data I'm interested in and getting it out of OPeNDAP for me. So I'm going to look for vegetation indices. So I'm going to type in veg for vegetation indices, and I'm going to pick the Mod 13 A1 005 16-day product, version 5. If I pick that, I get a list of the different bands that are available through OPeNDAP for that, and I'm going to pick the EVI band, and I'm going to pick the NDVI band. So I can pick the bands from that product, and AppEEARS is going to go get those out of OPeNDAP for me for the points and the areas and time I've selected. Now I want to compare those to something, and let's say I want to compare those to land surface temperature, so I'm going to put in temperature, and I'm going to pick the Mod 11 A2 product, which is an 8-day product, because that has it to compare to my 16-day NDVI product, and I will click on Mod 11 A2 version 5 and get that product. And in that case, I am going to ask for the land surface temperature band for daytime and get that, and I'm going to get the nighttime temperature and pick that. So I'm able to compare these variables from these different MODIS products together in the same analysis. If I submit this, it will send this job through, and AppEEARS will go through and utilize the web services that the LP DAAC has in its middleware layer to find out information about location, find out information about temporal areas within those products, and go create URLs that will pull this data out of OPeNDAP and create the output order for me in the system. So that's how we do extracting of information from AppEEARS. When we're done, we can look at the Explore tab and see that we have some information there. We have webinar demo, which I just put in there, so I've got the webinar demo, and it's processing. So that's what I just submitted. It's in the process of being processed. I did another demo earlier for the webinar, and that's processed here. And I did another one that I'm going to take a look at previously that's going to be a comparison of CONUS MODIS data in WELD and MODIS and compare the NDVI bands for there. So if I look at this information, I can find out that in that selection, I compared from January 1st, 2002 to December 31st, 2012. This covers the span of the LP DAAC's CONUS WELD data. I looked at the NDVI from the US monthly WELD product, and I looked at the NDVI from the monthly MODIS product, and I'm going to compare those. And in this analysis, there were points for nearly every state. I've got 48 data points from many different states to do that comparison. So I labeled, the points are labeled by an integer, and then we've got a category of state, so you can see the state values in there. So it's an analysis of MODIS data state by state and looking at NDVI in MODIS versus NDVI in WELD. So if we click on this graph button here in our Explorer, we get an analysis of that data in AppEEARS. So AppEEARS gives us some simple graphs that let us take a quick look at our data and kind of get a feel for what was pulled out of the OPeNDAP data view for all of these different pieces of data. So I can add a line here and see the time series. This is for the first site in the set for Alabama, and it's the Mod 13 A3 NDVI. If I want to see the WELD data for that, I can click on the layer for WELD, and I see the information for the WELD layer. So I can see different pieces of data by going through this interface. If I go to Colorado, I can select the Colorado information. It'll show me the NDVI data for that one, and there's some little issues with some of the data there where we have some interesting values. Or I can see the mod 13 values here for MODIS. So I can see those values and kind of go through and look at those values. When I'm looking at the temporal comparison, I can see stacked time series, so it gives me a view of this data over time. If I highlight this, it'll highlight the 2011, 2012 time series. I can also turn them off if I want to take them out of the comparative view. So it compares the different sets of data year by year that we've selected from the data set. We also look down here, there is a table that'll show you the data if you want to look through a tabular view and kind of go through your data and review what information came through your AppEEARS request and what information you got. You can see that information here. So you see how it's the monthly data and we get information. We also, in AppEEARS, automatically bring through the quality data. So we provide information about the quality of those bands, and you can see in some cases there was a visual vegetative indices was produced, but you need to check other QA because it's not truly sure. But in some cases, the VI was produced and it was good quality. So we include the quality data so that users can filter their data as they wish. And we include that automatically for the bands that we're dealing with. We have another tab here for our review of the data in AppEEARS, and we can do layer comparisons. In this case, we can compare for one site different layers. So it automatically compares the two layers that we picked, and we can add lines to look at the comparison. If we pick another site, we can compare other sites' information as well. So here's a comparison for Florida of those two layers. So it compares those two layers, and you can put them side by side. This is nice, and then a nice way to compare the layers that you're getting out, if that's what we're doing, and that, in fact, was the use case for this particular order that I created. Also on this screen and analysis area, we provide a scatter plot. So the scatter plot shows the relation of the two layers that you have selected. If you had more than two layers selected in your order, you would be able to pick and mix and match between those layers and do comparative analysis between all of the layers that you got in your order on this screen, and you would see scatter plots that would tell you how those layers compared. And in the scatter plot, it will actually tell you the values for both of those points as they are compared here. And again, we have another grid down here that shows you the information side by side in the comparative analysis. And then finally, we have in our analysis of the data a categorical overview. In here, it breaks down the categories of this data, and here we're looking at the mod 13 NDVI data. It shows you a breakdown of the quality values. So this is the data that has 0 for quality values, which means good quality values. These are the ones that have the suspect, the 1 values for the quality values, and more values with more issues with the quality value of 2 are represented in this band. So it breaks down quantitatively how much of your data is in which quality category and shows you that. It also breaks down by the categories specified in your order what's going on with your data. So it will show you the ranges and the qualitative range of your data for each one of the categories. And you see, of course, we had states represented as our categories. We're seeing them here. And then we had sites represented as our categories as well. So we have that, but that's a way to explore our data. If we want to look at our data closer, we can press the download button and actually download that data. I've downloaded it here in this tab, and I can show you quickly what the data looks like. This is what you get if you press the download link. You get your bundle of data. It has the results for your analysis, and it gives you that in a comma-separated value file. Because of technological restrictions, I don't have a means to open that in Excel and show it to you. So I converted it to text and can show you what that comma-separated value file looks like. It has all of the values that were pulled out of AppEEARS for all of the time slices that you wanted and gives you all of that information. You can see here that it's got all the information for Alabama. It's got the particular dates that it's dealing with. It tells you which tile it came from. It tells you the locations and gives you the value and gives you the quality breakdown as to what type of quality that data is. If we continue to scroll down, we would see data for weld and the weld NDVI pixel and its quality information. So that comma-separated value file is the data that the users can analyze, and it's only the data that they requested. As you can see, that's about 1 megabyte of data, and that comes from many hundreds of different tiles in the weld and the MODIS archive at the LP DAAC. In addition to that, we split the results out by file. So this is the MODIS results, and this is the weld results. This results file has everything together. These two have everything split out separately. We also give the user a granule list. This is what our inventory service is providing for the AppEEARS client. This is a list of all the granules on the data pool that had data pulled from them to do this analysis. And then we also provide the user a nice README that explains their job, puts forth their parameters, and tells the user what is the information about this bundle, what the parameters were, what was specified, and basic information about the data, and some notes about the products that were selected. Just a nice little thing that tells users what information about their order and how they made the request. And as I mentioned before, this JSON file is actually the parameters for the order that they also specified. And you could give this JSON file to somebody else, and they could run that very same order. That ends the demo portion here, so I'd like to switch back to the presentation mode and show a few slides to finish up our presentation. So the LP DAAC is planning on expanding its service offerings in the future. One of the things we're looking at is adding to AppEEARS not just the capability to do point samples, but the capability to do area services in the API and in the UI. So instead of specifying a point, you specify a bounding box, you specify a shapefile, and we'd actually do the OPeNDAP services that would get that information out of the OPeNDAP data layer. We're also looking at adding more quality value services that will tell you about the quality values for the different products that we're presenting in our UIs and our APIs. We're adding more data analysis services. And we're also looking to add more tile data sets in the data layer that will then be available through the middleware services all the way to the UI and the API. One thing that I did not go into very closely is that all of the things you see the AppEEARS API doing are represented by services that AppEEARS presents and makes available. So in addition to those services, the middleware services that I show, the API services that AppEEARS uses are also available to users to call directly. So you can actually call AppEEARS and get samples out of a particular set of data values in OPeNDAP for a particular date range, and that's how AppEEARS does its collecting of its data. Those services are also available to users to use directly as well from our services page. The area services I'm talking about as well are going to allow for the selection of data over more than just the pixel space. So when we do this, we're going to look at giving you a different view of the data. We're going to have to add more analysis capabilities and more delivery capabilities that give you that area space in, say, a viewable way or in some data format. And we're also going to look at in the future how we harmonize that data from different data sets. In our example, we showed how we looked at weld data versus MODIS data, and we found a particular pixel, and we could compare two pixels to each other. It gets a little more difficult when we're comparing weld data to MODIS data, and we're looking at areas because the pixel sizes are different, and we're no longer comparing just one pixel, we're comparing different numbers of pixels. So we'll be looking in the future at harmonizing our data and taking the higher resolution data and the lower resolution data and making them work together so we can see information through those. And that ends the demonstration for today and the presentation. For more information about our services, subscribe to our listserv. We are continually updating our services, adding to our middleware service capabilities, and like I said, in the future we'll be adding to our AppEEARS API services and some of our AppEEARS capabilities. We put that information out in our listserv and give you the URLs to our web services and point you to where you can utilize our services and how they can be used. We also occasionally on our listserv have tutorials about utilizing those web services and that will walk you through using those. So please subscribe. I'm going to switch it back to Jennifer, and she's going to do the follow-on polling questions.
Okay, thank you, Jason. Thanks, everybody. So what we'll do next is we'll move to our final set of polling questions. I will give these questions just a couple minutes or so, and then we'll move directly to the Q&A portion of the webinar. Okay, so we've had several questions asked so far, and I've been keeping track of those. So in just a couple minutes, we'll move to those questions. All right, thanks, everybody. Okay, only a few more seconds here, then we'll transition to the Q&A period. Okay, everybody, we will transition to our Q&A period here. And I've noted some of our earlier questions, so give me just one moment here. One of our first questions, let's see. A moment so that I can go back to that. All right. Okay, the first question was, is the source code available for this application? And this question was asked pretty early on into your presentation.
At this
and
point,
you had started on the OPeNDAP, I believe. David,
yes.
If that's not correct, please clarify for me. Thank you.
The source code is available for OPeNDAP. OPeNDAP is an open source protocol for getting data. We have not open sourced our middleware services from the LP DAAC, but they are publicly available to be utilized as services. I don't know, I can't really say at this time whether we're going to open source them at some point in time. If you are involved in NASA Earthdata, we do have some stuff that we're utilizing through their Earthdata Code Collaborative, which may enable you to look at our services and utilize some of them from that context. But to this point, we haven't decided whether to make our middleware services or our higher level APIs open source. They are all, of course, publicly available, though.
Okay, thank you, Jason. The next question is, does HTTP access also mean HTTPS?
Yes.
Okay, great. And then moving to our next question, let's see. Currently, the product in inventory middleware accesses Modus and Weld, I think. Will it access the complete LP DAAC archive soon?
I didn't explain that well enough. The inventory service can provide information about the entire LP DAAC archive. It is used by AppEEARS in the context of my demo that I showed to provide Weld and Modus information, but it also can provide information about other products in the LP DAAC inventory. But they may be products like Aster that are not represented in AppEEARS yet. But the inventory service does represent all the products in the DAAC inventory.
Okay, great. Thank you, Jason. The next question is, when you say web tiles, is that the same as web map tiles?
Basically, when I say tiles, I mean that the granular information for the data is in a tile structured format. That slide I had where I located the point and put the pin in the map, that is the grid tile setup for Modus. And every granule in Modus has one of those H and V coordinates, and that's that tile, always represents that location space. For Weld, it's a different looking map, but Weld is basically the CONUS, the continental United States information for Weld is 5,000 by 5,000 pixel tiles, and there's quite a few, I think it's 35 by 26 tiles for that, and they're in a different tile space, but our tile mapping service understands that coordinate space and translates from that latitude and longitude information into the tile and coordinate space. So it's really a file format more than anything in the tiled space.
Okay, thank you, Jason. The next question is, what is the timeline for the AppEEARS Area Services module?
Sometime in the future. We don't have any definitive timelines on that at this point in time.
Okay, what I can do for the individual who asked this question, I can put the two of you in contact offline so that you can keep abreast of any updates or ask any additional questions. The next question is, will the OPeNDAP service eventually require Earthdata login as well?
Yes, that is likely.
Okay, thank you. And then the next question is, and it says, with a disclaimer as being from a social scientist, do these services relate in any way to the USGS DataCube activities?
No, they don't directly relate, but we do have a few users of our OPeNDAP services that are doing DataCube sort of things, and they pull different layers of data out of through OPeNDAP that they know they're interested in and ingest them into the DataCube via that method. So we do have some people who do work with DataCubes who are using our OPeNDAP services.
Okay, thank you, Jason. The next question is more of a combination with the question. We would like to test data access in web map tile format. Should we contact you directly?
Yeah, they should.
Okay, great. And I will provide you with that contact. The next question is, are OPeNDAP services advertised in the CMR? Can you point us at documentation of how to discover OPeNDAP endpoints through the CMR?
Yes, OPeNDAP access is presented in CMR. When you look at granules in CMR and get a response back, you'll get a link to the OPeNDAP address for that particular granule. With respect to our aggregated granule layer, our aggregated granule access for OPeNDAP, that's not represented in CMR. So if you go into CMR, you can get an OPeNDAP URL, and that will point you to the individual granules. Our aggregation is not represented in CMR, but our aggregation does follow a standard structure. We have all the aggregated directories available at our base OPeNDAP layer, and if you pick on the product, it represents, like I showed, it represents the product information. When you pick that, you get the list of the granules, and when you pick on the granules, then you can dive in and do a query against the aggregated set of all time for those granules. But we don't have anything in CMR yet that gives you access to that aggregated view. It gives you access to the granule views at this point in time through OPeNDAP.
Okay, thank you, Jason. The next question is there a catalog for the aggregated services, or parentheses, data sets?
Not at this time.
Okay. And just, well, we'll give the Q&A a few more minutes here. I don't see any further questions, but while we're waiting, in the bottom right-hand corner of your screen, participants, you should see a file sharing pod, and both the agenda as well as Jason's presentation are available for download there. So if you were to highlight either one of those files, left click, you should be prompted with an option to download the file. So I wanted to mention that to you, as well as to tell you that all of our webinars are posted to the online catalog, which is the tinyurl.com Earthdata webinar. If you access a webinar through that URL, the file sharing pod is a persistent feature, so you would be able to download the files at a later point in time. If you access them by way of our NASA Earthdata YouTube channel, you will simply be getting the recording. Just a couple of points for you to be aware of. And there are currently 56 data discovery and data access webinars or videos and tutorials available on our YouTube channel. If you've not visited before, you may find something of interest. The next question is there a catalog? Oh, excuse me, my apologies, I've read that. What was the graphics library that was used?
For what? Is there any clarification on that question?
David, could you provide some clarification? HTML client.
Oh, the HTML client? That is, I think we're utilizing Bootstrap for the API.
Okay, thanks, Jason. The next question is, what are your plans for future presentations? So I'm not sure, or better yet, what is the best way to keep in contact with this effort?
I think the best way to keep in contact is to subscribe to our listserv and watch our news feed from the LP DAAC. When we release a new service, we generally put out a news blurb and a listserv blurb about that and point users to it. Again, I'll also mention that one of the things we're striving to be very consistent with is making our services all have that help context, so that when you access the service, if you don't know how to use it, it will actually give you information on how to utilize it. So pay attention to our listserv and our news list, our news feed, and we'll be presenting more and more of our services out there. In the next few months, our product service is going to make its appearance there. So.
Okay, thank you, Jason. And what I've done is I've typed into the Q&A pod the URL for the LP DAAC website. But again, the listserv information will be in the presentation. And certainly if anyone has any questions, you are welcome to email me afterward. We do have a few more questions here. Okay, so David, have your questions been answered regarding the graphics library? I see there's a follow-up, time series graphs.
Oh, that. Contact us directly and we can give you more of that information. I'm not exactly sure. I know we actually utilized one module for doing the graphs and then switched to a different one. I don't know exactly what module that is, but if you contact me, I can get you information from our developer that'll let you know how we did that and what we used.
Okay, so David, I'll put the two of you in contact after the webinar, okay? And then the next question is, do you have a sense for how many users access LP DAAC's OPeNDAP services in any given week or month?
We're still kind of working through our metrics on that, so we have a very loose concept of that, but are working on getting our metrics into NASA's EMS system to do reporting on that more concisely. We have a loose sense, but not a very strong metrics component yet, but we are working on improving our metrics and adding more metrics capabilities to OPeNDAP.
Okay, and then one of the participants has added, Kevin has added, the AppEEARS HTML web interface uses dc.js, and there is a URL here from GitHub for charting. And then
that's
Lindsay,
straight from the developer, so that's what you'd want.
Okay, perfect. And then Lindsay Harriman, who's also out at the LP DAAC, one of the communications leads, has provided the listserv for subscription into the Q&A pod as well, for those of you who might be interested. Are there any further questions? You're welcome. If there aren't any further questions, this is what we'll do. I'll give it a minute or so. We'll then log off from the telecon portion of this webinar. But generally, I will keep the virtual meeting space open for 10 minutes or so for those of you who might be interested in either downloading the files or you've thought of another question that you might want to ask. And so, Jason, I would ask if you could stay on the line for an additional 10 minutes, stay in the meeting space after we hang up. That would be very helpful.
Okay.
So, anybody have any further questions? If there are no further questions, okay, here we go. How do we get the slides? So Jean, the slides below the Q&A pod here, if you highlight the first link or the first one, which says LP DAAC BEDI developed web service, that is Jason's presentation, and when you highlight that by left-clicking, you should be prompted to download the files. If for some reason that does not work, please feel free to email me. This is Jean from ASF, right? Do I have that right? ASF DAAC. And you're very welcome, Dimitri. We're glad that you enjoyed it. All right, well, fantastic. Thanks so much, everybody, for joining us. If there are no further questions at this point, we will log off from the telecon. And again, I will keep the virtual space open for those of you who might be interested in downloading the files or you've thought of something to ask. All right, well, thanks so much. All right, bye-bye, everybody.